everyone. In this video, we're going to look through some of the things about polynomials like we saw in our last lesson together. So take a moment, try this do now, same thing we were doing on our last lesson. Pause the video here and just take a moment to find the roots and the y-intercept and then make that sketch. After you've done that, you can come back in. All right, welcome back. So as we know, whenever we have to find the roots, we're using factoring. So with these four terms here, we can factor nicely. And to factor nicely, we're going to take the GCF of both of those two groups here. I pull out that x squared to have an x plus 2. Pulling out a negative 9 to also have that x plus 2. So I'm going to have x squared minus 9 with our x plus 2. We know we can go a step further in that because we have that x squared minus 9. So I'm going to pull out that dot situation here. And as always, when you're trying to find the roots, that is another name for the zeros or the solutions. So I'm going to set that equal to 0. So that we get x equal to negative 3, x equal to positive 3, and x equal to negative 2. So we get all of our x-intercepts there, our roots that are going to be on this graph. To find our y-intercept, it's kind of nice here because we know it's just whatever this last term is. Because while we set y equal to 0 for the roots, we're setting x equal to 0 for the y-intercept. So really, even when I plug all of that in, I know I'm going to be looking at a negative 18. So putting that together here, just to get our sketch in play, with our idea here, the big thing with your sketch is that you include all of your intercepts on that graph. It doesn't have to be drawn to scale in any way, but we know we had a negative 3, negative 2, a positive 3, and way down somewhere here, we got a negative 18. Again, we do not need to be drawn to scale in any which way. We just have to make sure we pass through those points. Your curves, you don't need to worry about too much either. So we know this is a cubic. We're looking at something like such. That way it passes through each of those zeros that it's supposed to be, all those x-intercepts that are shown, and we have that negative 18 as my y-intercept. So we get information from standard form and this roots form a little bit nicely depending on which type we have. So let's kind of look at that for a minute. So we just saw it was given to us as standard form to start from the do now. So our standard form, that was this y equals x to the third plus 2x squared minus 9x minus 18. That roots form, well, that looks like when we had it in factored form, when you have y equals, and we had that x plus 3, x minus 3, and that x plus 2. So both of these things get us different key information as we're going for. Like, the first thing I'm thinking about is the degree. We know the degree is our highest exponent. And with that, what's nice about the standard form is you can see that plain as day, right? That largest standard form, that first exponent comes along, there's my 3, we're good. I know that with the roots form as well because technically what I'm looking at here is like each one of these has a 1 as the exponent up there. And we think about if we were to multiply all 3 of these out. But really, we're just thinking about that x times x times x situation, which gives me that third power. So in standard form, we know it's just that highest exponent. In roots form, we see how many roots there are. So we use the roots. All right, we see how many roots there are. We think about how many powers there are. So we think about something like that in that scenario. Now my leading coefficient, My leading coefficient, we can see nicely in both cases. We know that that's technically the a. So it's whatever in front of that x to the third there. So my leading coefficient is the a value that we search for. So in this case, both scenarios, it's that piece in front, right, that 1. But that's going to be my leading term. Now the roots, we learned about the fundamental theorem of algebra in our last lesson. So the roots kind of stem from the degree, right? We know whatever the degree is, we know that that's how many roots there will be. So I know that there's going to be 3. But what's nice about that standard form, it's just setting the factors equal to 0. And then our y-intercept. As I look at my y-intercept there, it's really a matter of, we know that negative 18 is nice. It's that constant piece at the end. But it's also, when I'm looking at it, like for the roots, we would have to go a step further and we'd have to plug in. So we plug in x equals 0 there, right? Because then we'd have to have like a 0 plus 3 times a 0 minus 3 and a 0 plus 2. And when I multiply that 3 times negative 3, we get that negative 9. Times 2 is going to get that negative 18 as well. So depending on which form you have each piece in is kind of like telling you how easy you can find certain factors or ideas about the polynomial in question. Now, a question that came up on our last lesson was, how did I know the direction? Like, how did I know it wasn't like a down? Like in this do now, we see that it went from down and then up, right? So let's kind of get a rule going for that. So that's going to refer to our end behavior. So we started to talk about it in some groups, but let's talk about when the degree is odd. So an odd number being 1, 3, 5, 7. What that means, that odd, just like that cubic we saw, the end behavior goes in opposite directions. So as I look at that, we have one of two scenarios that's going to happen. We can either go down then up, like we saw in the do now, but maybe there's a case where we're going to go up then down. And again, we're talking about the end behavior, the end. So that scenario is going to come from the leading coefficient. Remember that a we just talked about. A would have to be positive to get this to end going up. Our a value is going to be negative, so that way we end down here. So these are my two scenarios of what can happen. But maybe something changes with my degree. My degree is even, let's say. My end behavior is going to go in the same direction, right? Because like we're thinking like a 2, a 4, a 6, an 8. We are going to have this end behavior goes in the same direction. So we're looking at either an up, up, or a down, down. And again, it comes back to our a value, right? So if I think about x squared for our value, a is going to have to be positive to make them both go up. If a is negative, then we're looking at our down frown scenario. So that's kind of our idea. So what people will do to kind of help themselves with this is they'll make themselves a little chart. because there's not too many scenarios that can happen. But again, two big factors. We're either dealing with an odd or an even degree, and we're either dealing with A being positive or A being negative. So when I think about something like that, odd, opposite, but it's going to end positive. Even, they're going to both be going up because they always end with the behavior that we're talking about, this positive or negative. For the odd, with that negative, we'll switch it. And even will go down and down. And you don't have to set it up exactly like this chart, but it's just whatever way kind of works for you to do this setup here. Now, end behavior does get a specific notation. Now, in this, I'm going to borrow my cubic again, just kind of like what we saw in that do now. And this, if I just picture a graph here, so that's kind of like what we saw in our do now, right? And we know we have our x-axis and our y-axis. And let's call this my polynomial p of x, right? So there is a very specific end behavior notation that can arise as we go through. So the first of it will say, like, as x approaches infinity. So that's what this symbol means. So as x approaches infinity, so let's think about where that's going to fall, right? So that is as the x is going to positive infinity. It's going to greater numbers. It's going to the right. So when x is going to the right on our graph, we want to know what the end behavior is doing, what the polynomial is doing. So we say p of x, which is your function notation, but essentially it's the same as having your y value, right? What's happening with that is we're seeing what the function's doing. So as I'm going to the right here, I see that this is going up towards positive infinity. So we talk about it going up. So if I look at it the opposite way, so if x is going towards negative infinity, that negative infinity now is looking for negative numbers, so I'm going to the left this time around when I read through that. And when we think about what the function itself is doing, p of x, now that happens to be going down. So down for us is going to be that negative infinity idea. Again, we're talking about function notation, so we're using that as the y value, but we're looking at x and y. So that would be like our formal write-up of the end behavior and which way it goes, just to kind of model it from that do now. So in here, we got a couple examples just to kind of go with now putting all of these pieces together as I look through. So if I look at this first exercise here, what is the degree? Well, it's in standard form, so we know it's nice and easy to spot that degree. It's our highest exponent, so we know 3. Our leading coefficient lies in front there, so we know we need to deal with a positive 1. And my y-intercept, well, I've got the graph right here, so I don't even have to worry about that. We see that 0 happening in that case. So what I'm looking for is as the x value becomes more negative, right? So it's going more and more negative. So what that means in general, x is going towards negative infinity, more and more negative. What happens to the y value? That's my left end behavior because we're talking about negative infinity. Well, when I go to describe that, again, we're talking about the function. So as I'm going more and more left, I'm seeing this coming to the negative. So p of x is that function notation going towards negative infinity there. As I read through that second piece, as the x value becomes more positive, right? So we're going to the right now, bigger and bigger positive numbers. Again, when we look at this end behavior idea, it's going to the right. I see it go up, so that's where my p of x is going towards positive infinity. And that's on the right side, so it's my right end behavior. Okay, so we can see different things along the way in there. Now, in this case, consider the polynomial function with this p of x is equal to x times x minus 3 squared. Well, it's already factored for me, so find the y-intercept. Well, we know that's going to be a 0 because we're plugging in 0 times 0 minus 3 squared, but as soon as we saw that 0 in front, we know that. For the roots, we're setting them equal to 0, so I get x equals 0. I get x equal to 3, and now it says behavior at each. So remember that x equals 0, that has a multiplicity of 1. It's got that 1 degree there, so we know at x equals 0, it's going to pass through. And what I mean by pass through, I mean to pass through that x-axis there. But for this 2 with that degree here, that's a multiplicity of 2, and that creates that bounce effect. So at x equals 3, we're going to see that bounce off of the x-axis, that ricochet. We know in front, we have a nice positive 1, so sine of a is positive. With my degree, I have 2 solutions, but remember we count that multiplicity in there. So really this is going to be a degree of 3. And so with my end behavior, that means I know it's going to end positive, but it's an odd degree, so they have to go in opposite directions. So that kind of gave me a little bit more footing as I go. And then I'm ready to go ahead and graph this piece. So we're going to have 0 as our x-intercept and our y-intercept. We have a positive 3, and we have this idea that we know we're starting down. Somewhere we'll turn, but then we're going to bounce there, making that cubic shape that we expect to see. Now, what we've been waiting for here is this negative out in front scenario, right? So in exercise 3, I've already got it in factored form. So finding our y-intercept, we'll plug in that negative. 0 plus 2, 0 minus 1, 0 minus 4. So I'm looking at 2 times a negative 1, negative 2 times a negative 4 makes that positive 8. But then we can't forget about that negative that was out in front. So we're looking at a negative 8. My roots are when we set each factor equal to 0, right? Like I want to make it very clear, even though there is a 1 out in front like this, negative 1 does not equal 0. So that is just a factor in front, right? That's the a value. But my roots are going to be a negative 2, an x equal to 1, and an x equal to 4. So I'm going to go put them on there. My negative 2, 1, and 4. Our y-intercept somewhere down here at negative 8. And we know each of those roots only happen once, so they're all going to pass through. And now we see the change. So that change of that negative 1, that negative a value with a degree of 3, we're going to end negative this time. So it means we're going to start positive. So now I know the previous questions were, well, how do we know? The degree and the a tell us that direction. As long as I pass through those 3, that's what I'm looking at roughly, right? So again, it doesn't matter where your turns happen, as long as we hit all of those intercepts, those 3 x-intercepts, that 1 y-intercept, then I'm looking at this function that I've got here. Okay. So in this scenario for exercise 4, we've got another roots scenario, As I look at that roots form, my y-intercept again, we're just plugging in 2 times 0 minus 1, 0 plus 3 squared, 0 minus 5. As I plug that all in, I know I'm dealing with 45. Because I'm looking at 3 squared for the 9 times a negative 1 is a negative 9, and then negative 9 times negative 5 is positive 45. My roots, same thing. Right, we're setting each equal to 0, so I'm going to get x equals that positive 1/2, x equals a negative 3, and x equals a positive 5, knowing that for that 1/2 and that 5, that's going to be a pass-through. They only have a multiplicity of 1 in that case, but we know that x plus 3 squared is my multiplicity of 2, so we'll see a bounce at that negative 3. My sign of a, back to the OG, in the beginning we got that positive 1. Degree this time is going to give us a 4, because we're looking at the degrees, right? There's 3 solutions, but that negative 3 counts twice. So it's like this is 1, this is 2, this is 1. We add that up for that 4. So that means up and up. Positive end behavior, same direction because it's even. And then we get our sketch. And again, we're not worried about being drawn to scale. We're worried about getting that 1/2 on here with that 5, with that negative 3, and yeah, 45 is pretty large, so somewhere towards the top there. But again, that's why it's called a sketch. It's not a drawn to scale situation. We are getting that sketch on there, and now we know we're starting up. We're bouncing at that negative 3 like we said, passing through 45, coming through to do some kind of 1/2 and 5 scenario. All right, hopefully that gives you the good footing. I've got 2 more on there with this exercise 5, and we have an exercise 6 in there. Looking at your lesson, go take a moment, try it. You've got a roots one, you've got a factor first one. So get that practice in, see how you do, and then we'll be back. You'll have lesson 3 as a video homework tonight.